Now this is one of these exam questions that at first glance looks really tough. It's designed that way. Like many exam questions, they'll throw in a little twist to make something you actually know really well look like something you don't know how to solve at all. If you practice enough though, nothing is beyond your scope in an exam. Don't let a question throw you just because it's written in a slightly different way or it looks weird. It's all stuff you've done before. So let's give this one a go. Now if we know that m to the power x is equal to mn and n to the power y is equal to mn, well it follows that m to the power x is equal to n to the power y. That's straightforward. But what we want to do is we want to try and find some format where 1 over x plus 1 over y is equal to something. So that's what we're looking for. So what we're going to do next, we're going to raise both sides to the power 1 over x. So that's m to the power x over x is equal to n to the power y over x. Now, x over x is just 1, so that implies m to the power 1 is equal to n to the power y over x. And then we're going to raise both sides to the power 1 over y. So that implies m to the power 1 over y is equal to n to the power 1 over x. So that's us got our two parts here, 1 over y and 1 over x. Now, if you remember that log to the base of something is equal to 1, that implies that the something to the power 1 is equal to the something. So let's go ahead and take log to the base m of both sides. So log to the base m of m, so 1 over y, is equal to log to the base m of n, so 1 over x. And then it follows that log to the base m of m, well that's just 1. So that means we've got 1 over y is equal to log to the base m of n of 1 over x. And also using our log identities, this 1 over x can come down and multiply in front of the log to the base m of n. So then we've got 1 over y is equal to 1 over x multiplied by log to the base m of n. So now what we want to do is we want to write down 1 over x plus 1 over y. Now that is equal to 1 over x plus 1 over y, which is equal to 1 over x times log to the base m of n. So all I've done here, I've substituted this in for that there. So we're going to take out a common factor on the right hand side. So we've got 1 over x plus 1 over y is equal to 1 over x, in brackets, 1 plus log to the base m of n. Now we also know that from above that m to the power x is equal to m times n. So what we're going to do is take the logs of both sides, but if you remember the log identity of log to the base question mark of question mark is equal to 1, then what we're going to do is take the log to the base m of both sides, and it means we can get rid of this m on that side. So let's rewrite this then. So we're going to have log to the base m of m to the power x is equal to log to the base m of m times n. Now, log to the base m of m, that's just 1. And of course your x can come down and multiply in front of that. So we're going to end up with x is equal to log to the base m of m times n. Now, on this side, we're going to use the log multiplication and addition formula. So that means we can rewrite this as x is equal to log to the base m of m plus log to the base m of n. Now, that is just 1. So it means that x is equal to 1 plus log to the base m of n. Now, we're going to take this here and substitute it back in, away up here, to this part here. So what we're going to end up with is 1 over x plus 1 over y is equal to 1 over x, which is the same as 1 over 1 plus log to the base m of n, multiplied by 1 plus log to the base m of n. And of course, 1 plus log to the base m of n divided by 1 plus log to the base m of n is just 1. So that means we know that 1 over x plus 1 over y is equal to 1. Now, we also have the formula e to the I pi plus 1 is equal to 0. So that means 1 is equal to negative e to the I pi. So if we substitute this in, we're going to end up with 1 over x plus 1 over y is equal to negative e to the I pi. Now, let's multiply both sides by negative 1. So we need to put brackets around this. We're going to have 1 over x plus 1 over y, and we've got our negative 1 here, so it's just a negative, and that is equal to e to the I pi. Then we're going to raise both sides to the power of 1 over I pi. So we're going to need big brackets here to put everything in. So it's negative 1 over x plus 1 over y raised to the power of 1 over I pi is equal to e to the I pi times 1 over I pi. And that is equal to, big brackets again, negative 1 over x plus 1 over y raised to the power 1 over I pi is equal to e to the I pi times 1 over I pi, and of course that's just e. So now what we're going to do is divide both sides by e, so we're almost finished. So we're going to get e to the negative 1, all multiplied by, inside the brackets, negative 1 over x plus 1 over y, big bracket again, 1 over to the power 1 over I pi is equal to e over e, which is just 1. So there we go. That's us managed to prove that e to negative 1, all multiplied by negative 1 over x plus 1 over y, all to the power 1 over I pi is equal to 1.